Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to be taking a look at arithmetic sequences again, but we're going to be looking at how to find how many terms, the number of terms, in a finite sequence. So let's go ahead and get started. Now, when we're talking about a finite sequence, essentially what we mean by that is that it has an ending point. So you know that a sequence always has an initial term. And generally, what we looked at in the past is you have an initial term like 1, as an example, and 2, 3, 4, and then you have like these ellipses like this, and then it kind of finishes out. This ellipses part right here means that it just kind of goes on forever. That's what's happening here. It doesn't stop. But now we're doing it slightly different. Instead, what's happening here is that we're going to have our ellipses here, and then we're going to have a terminal point, basically. In other words, there comes a point where the sequence comes to an end, and that is what we're going to be looking at today. So let me see if I can give you our first example here. So let's just imagine that we have the following arithmetic sequence. And one thing I need to mention is that when we're talking about arithmetic sequence, we're talking about we have a clear pattern, and the difference between terms, adjacent terms, is always the same throughout. So you can see right here in my first example, the difference is here is 1. 1 goes to 2, 2 goes to 3, 3 goes to 4. It always increases by 1. Now let's go to our actual example for today. So imagine, let me just go ahead and delete this. We don't need this anymore. I have the following. I have the numbers 9, then it goes down to 2, then to -5, then I have my ellipses, and then it goes to -40, and then we finish it out. And so what we want to do now is we want to figure out how many terms do we have when we go from +9 over here all the way to the left to -40. How many terms do we have, bearing in mind that this is an arithmetic sequence and the distance, or the difference, between adjacent terms is always the same. So you can see here that we are subtracting by 7, because 9 minus 2 is 7, 2 minus 7 is -5, 2 minus -5 is 7, etc. So the difference is subtract by 7 each time. We know that. Now I'm going to put up the generic formula first before we start to work this out. So our generic, well, that's too dark. Our generic formula is going to be A sub n equals A1 plus D times n minus 1, like so. That's kind of how it works out. Now, first thing we got to figure out here is what is our difference? And so to do that, we just take two consecutive terms. I've already talked about this. So D equals A2 minus A1. And so for our situation, A2 is 2 minus 9. Our difference is -7. We've already talked about that. There's nothing surprising there. So now we're going to plug this into our original equation and try to work it out. So A sub n equals, our A1 is 9, minus our difference of 7, times n minus 1, like so. And we just do some really basic algebra here. So we want to distribute this -7, so we get 9 minus 7n plus 7. And then we just combine like terms, so 9 plus 7 is going to be 16. So our final answer here for our actual explicit formula is going to be 16 minus 7n. Now, this is where things get complicated. To figure out our answer, what we do is this. We take our final term here, right here, and we plug this into our A sub n. That's what we do. So let me show you this on the next slide. So what's happening here is I'm going to take -40. You've seen this before. That is our final term. I guess you could call it our terminal term. I think that's the official term. No pun intended there. Equals 16 minus 7n. And so we just solve for n. So we want to isolate the n. First, we're going to subtract 16 from both sides. And so now we have 56. This is a -56 equals -7n We divide both sides by -7, and you can clearly see that it's going to be +8 equals n. That is our answer. In other words, -40 is our 8th term in our actual sequence. And since -40 is also the last term, the terminal term, we can say with confidence that there are 8 terms in this sequence. However, we don't have to take my word for it. We can check. So if we go back here, let's see here, we can plug these numbers in. Real simple, right? So this is term number 1. So if I plug in 1 here, 1 minus 1 is 0. -7 times 0 is 0. And so you're left with 9. This is my second term. If I plug in 2, 2 minus 1 is 1. -7 times 1 is -7. 9 minus 7 is going to be 2. And so you can see that it's starting to work out. And of course, if I plug in the 8th term, my 8th term right here, this guy right here, 8 minus 1 is 7. 7 times 7, -7 times 7 is 49. 9 minus 49 is -40. So you can see that it works out. If we actually plug in our different terms here, 1 and 2, or all the way to 8, we will get the results that we expect. And so we know that this particular formula works. And of course, yes, we could have used this formula down here. This is the simplified version. I just used this formula up here. It doesn't matter. They will both give you the same answer. If you don't believe me, let's see here. We put in 1. 7 times 1 is -7. 16 minus 7 is going to be 9. So it's the same thing. All right. So let's do one more, shall we? And try to conclude this video. So here's our second sequence, if you will. So I'm left with, I have these values 6, 11, 16. Then I have my ellipses. And I stop at 56. And so we go through the same process. The first thing that we need to do is we need to find the difference. So I'm going to take my A1 and my A2. And so it's going to be, difference is going to equal 11 minus 6, and that's going to be 5. All right? And so now, in case you forgot the generic formula, it's A sub n equals A1 plus D times the quantity of n minus 1, like that. So now I'm going to plug in my D because I already know that, and I'm going to plug in my A1 because I know that as well. And so I'm going to get, let's see here, 6 plus 5 times n minus 1. I'm going to distribute the 5. So I'm going to have 6 plus 5n minus 5. And I'm going to end up with 5, excuse me, yes. Let's see here. I'm going to end up with, let's see here, 1 plus 5n. That is our answer right there, at least for the explicit formula. Now I have to plug in the 56. And so I'm going to have the following. Just change the color here. I'm going to have 56 equals 1 plus 5n. I subtract 1 from both sides. Then I get 55 equals 5n. Divide by 5. And the answer is n equals 11, or 11 equals n, however you want to call it. That is kind of our answer. In other words, in this sequence right here, there are 11 terms, and they're increasing by 5. So 6 goes to 11, 11 goes to 16, 16 probably goes to 21, etc. And of course, we're going to check real quick. I'll put a little space right here. So if I put in my A1 term, if I just put in 1, so we're going to do 1 plus 5 times 1. Well, that equals 6. And of course, if I do 1 plus 5 times 2, you can see 5 times 2 is 10, plus 1 is 11. Well, that's the second term. It looks like we're doing pretty well here. Let's do the third term. So 1 plus 5 times 3, well, that's 16. And just for fun, do the 11th term. 1 plus 5 times 11, yes, that equals 16. So it looks like we have the correct answer. We checked it and verified it by plugging in each of our terms here. So let's summarize what we talked about and conclude this video. So in this video, we looked at how to find the number of terms in a finite arithmetic sequence. And so in order to do that, of course, you got to make sure you know your generic formula right here. A sub n equals A sub 1 plus d times n minus 1. And then, of course, the first thing you want to do is you want to find out what is your d. And you take any two consecutive terms and you just subtract them. So I took a2 minus a1, and I got my answer here. You plug this in for d, and then you simplify the expression by just distributing stuff, removing the parentheses, not that deep. Once you've completed that, you need to plug in your terminal term, if you will, the last term, to see how many terms are in the actual sequence. In other words, you want to solve for your n now. That's what you're doing. This is kind of the opposite of what we did in the past, but let's not get stuck on that. And so once you do all that, you can see your answer here. And if you want, you can always go back and check and verify this if you want, either mentally or you can write it down, however you see fit. It's up to you. So I hope that this video made sense and you were able to understand the ideas that we talked about here. My name is Darren Thomas. I'm the Director of Educational Research Techniques. Take care.